So in this video I'm going to talk about the resistors. So first of all we will go from the definition. What is a resistor? Resistor is nothing but a two terminal element. You can say it as a component used to which is used to oppose the flow of currents or electrons. Okay, so this is a definition of the resistor. We can use the resistors in two terms. One thing, we can use a single resistor, and there are other two ways, that is we can use a combination of resistor. So combination of resistor is nothing but series and parallel. So let me tell the formulas for both. I will not tell the formulas, I will go you to show the resistor how it is used. So let me go for that first. So to show that, I am going to use a software known as Proteus. So the Proteus software is, I am going to open it now. So this is a Proteus software where we can simulate any component and learn about them. So I would have showed it on the breadboard, but I don't have the many voltmeters or many ammeters. I'm having a single multimeter that I already shown in some video. So let me use this software to tell what I am going to tell about the resistor. So let me make one new project. So by clicking on this new project, then I will browse where I want to save it. I want to save it on a desktop and YouTube Proteus. Then I will select this folder. Then I'm going to name it as a resistor, as I'm going to tell you about the resistors. I have named it as a resistor. Then these all things are default. Let me press just enter, enter, enter. Okay, finish. So this is all I have made. Now let me take one resistor first. I will click the P, then I will take a resistor, resistor. So I am getting this resistor, then I will press OK. So once I took the resistor, you might be seeing there is one sidebar where here it is written as P and L devices. Whatever I choose, that will come here, and you can take it as many times you want. There is no cost for it. It is free. So you do anything in these softwares. You can do any experiments so that you can understand anything. There must be some harm while you're doing in the breadboard, but there is no such harm while you're doing in this software, as it does not burn or it does not bite you, because you can do any experimental things in this such of type of software. One is Proteus I use, and one more, there is a software known as LT Spice. So and then we will, this the value is having a default value, that is 10k. We can change it by double clicking on that component. Here it is written 10k. I will make it as a 1 ohm for simplicity for now. Okay, so this is a single resistor. You might be seeing that is a two terminal component. Now let me take the voltage source. So voltage source I'm going to take. Why am I taking voltage source? Because resistors is always used across a voltage. That is a simple thing in this resistor. So let me take one voltage source. Let's search the voltage source. Here it is written as a DC voltage. Let me take a DC voltage. Then I will place it here. Now I am going to connect it to the resistor. Positive end to one end, negative end to other end. So now I have connected the resistor with the voltage source. By seeing this, you might be feeling the voltage source is connected to the resistor, but how it is connected? It is connected in parallel with the resistor. So whatever the voltage it is giving, that is going to be dropped across R1, that is 1 ohm. What is a current that is flowing in this circuit? You can find it easily by using the Ohm's law, that is V equal to I into R. So to find the current, we are going to make it as I equal to V by R. So what is the V value? 1. And what is the R value? That is 1. So current is going to be 1 amps. So to show it more convenient way, I am going to connect one voltmeter and ammeter to this. Let me take one voltmeter and ammeter. So to find the voltmeter and ammeter, we are going to go for the sidebar. There is known as a virtual instrumentation mode. So there you will find the oscilloscope, every meters you want. So let me take one DC ammeter. and one more I will take it as a DC voltmeter. I will connect ammeter in series with resistors because ammeters are always connected in series. And one more thing, ammeter have a zero resistance, so there is no drop of voltage across the ammeter if you connect it in series with the resistors. That is a property of ammeter. And there is a property of voltmeter, that is what the voltmeter has an infinite resistance, so there is no flow of current in the voltmeter. Voltmeter always, there is a zero drop across voltmeter. So that is what about the voltmeter and ammeter I want to tell. This is a very important thing to know about the voltmeter and ammeter, which many of them don't know. What is it? Ammeter has a zero resistance, so if you connect it in the series with a resistor, it is going to act as a wire and it does not take any drop of voltage. And one more thing, voltmeter has an infinite resistance. And one more thing, voltmeter is always connected in parallel with the component which you want to find the voltage. And voltmeter has an infinite resistance, so it does not take any current into it. So that is what I want to tell you about the voltmeter and ammeter. Now let us connect. By deleting this wire, I am going to connect the ammeter. So this is the ammeter I will take. I will connect it here. So it is in series. Let me make the circuit with a neat, and then I'm going to connect the ammeter across the resistance. Let me rotate it. Let me rotate it. Rotate. I would have rotated it anti-clockwise, but I made a mistake. So then I will connect it here. So this is connected in parallel with resistance. Then I will complete this circuit. So now, according to our calculation, it has to be 1 amps, 1 volt. So 1 volt across resistance and 1 amps in the total circuit, the current has to be flowed. So let me run this. So you might be seeing that is 1 amps and 1 volts. So this was all about using the single resistance thing. Now, now let me bring the combination of resistors. So I will make a one more circuit to make it more understandable. So component mode, you have to go for the component mode for whatever you are taking the components. Now let me take the two resistors and tell you how the combination is going to work. Now first combination I am going to say it is series. So in series combination, to connect the resistor in series, I have took one resistor and I have took another resistor. Now to connect them in series, how you are going to connect? End to end. So this end is connected to this end. So this combination is known as is in series. If you took the, there is a resistance meter also in multimeter, you might be seeing it. I don't think so there is presence here, so I will tell you how it is. If you took the multimeter and connect one end to here and another end to here, you are going to see the total resistance of 20k, because this is 10k, this is 10k, that is going to be 10k plus 10k, that is 20k. In series you are going to add them directly. So this is a resistance R equivalent formula, that is this is R2, this is R3. So R2 plus R3 is going to be R equivalent resistance of in series. Now to tell about series connection, one thing you have to always remember in series connection is that the current is going to be same in both the resistor. Okay. And second thing you have to remember is that whatever the total voltage you are going, that is to be divided in both the resistor. I'm not going to say it is has a equal. If you keep the resistance equal, then the voltage is going to be divided equally. We will see every case here. Let me change first values of this resistor. I will keep them for simplification as 1, so that it is more understandable and more easy to calculate for now. Always go with the small things, then you will understand the big things very easily. Now let me take one voltage source. So I will connect it. Now let me rotate it up first anti-clockwise. I have rotated it. It is already 1 volt. There is no need of changing it to 1 volt. Then I have connected it here. Then I will connect it here. Okay. This is the connection I have done. So what is going to be the voltage across R2 and R3? Let us take one pause. I've already given hint about this, I guess around 10 seconds ago. Now, what is the voltage across one R2 and R3? Tell me by taking the pause. Now I am going to answer it. So the resistors are equal. So whatever the voltage, total voltage it is there, it is going to be divided equally. So it is going to be 0.5 volt and 0.5 volt. Now we can verify by that taking the again the DC voltmeter. I will connect them in parallel to this and this. So let them be this way only, and we can connect them parallel like this also. I have connected them in parallel. So now let me run this. As you can see, that is 0.5 volt and 0.5 volt. One more important formula I am going to tell you that is going to be used many more times in the electrical branch and all. So that formula is voltage divider formula. What is the voltage divider formula? I am going to tell it in a very simple way. You want voltage across R2, so you take the R2 value, that is 1 ohm. Then if you want the voltage across R2, so then take the value of R2, that is 1 ohm, then multiply it with the total voltage, that is 1 volt, then divide it by R2 plus R3, that is going to be 1 plus 1. So it is going to be 1 into 1 divided by 1 plus 1 is going to be 2. So 0.5 volt is the voltage across the resistor R2. Let me tell you in a clear way what is the formula. So if you want the voltage across R2, so VR2 is equal to total voltage, that is V, means in this case you are might be seeing it as V2. So let us write it as V2. So V2 VR2 is equal to V2 into whatever the resistance voltage you are want to find, that is R2 we want to find, let us write it as R2. So V2 into R2 divided by R2 plus R3. So this is the formula you have to always use when there is a series connection and you want to find the voltage across some of the resistance, some of the resistor. Then if you want to find the R3, it is the same formula, but it is going to be what? VR3 is equal to again same voltage, that is V2 into resistance R3 divided by R2 plus R3. So this is a voltage divider rule. Okay, you can find it very easy. Now we will, to make it the verification of that rule, we will make this as 2. Now we will use that formula directly. So we want to find the value of voltage across R3. So we will use the formula, that is VR3 is equal to total voltage is 1 into then R3 value is 2 divided by total resistance, that is 1 plus 2. So it is going to be 2 divided by 3. What is the value of 2 divided by 3? 2 divided by 3 is going to be 0.66 volt. So according to our calculation, the voltage across R3 is going to be 0.66. So let me run. So it is as it is 0.67 is the value. So this is one shortcut formula, that is voltage divider rule. So I have already told about current. Current is going to be same in the whole circuit. But what is the current is going to be? To find that we have to do R2 plus R3. That is we have to add the series resistors. So 1 plus 2 is going to be 3 and voltage is 1. So 1 by 3, because Ohm's law I equal to V by R. So 1 by 3, 1 by 3 is going to be what? 1 divided by 3, that is going to be 0.33. Let us connect one ammeter and see I am right or no. 0.33 amps is going to be the answer. Let us connect it here and see. We will delete this wire, then we will connect the ammeter here. So I have connected the ammeter. Now let me run it. So 0.33 amps the value. So always remember in series connection current is going to be same and voltage is going to be divided according to the resistance value. And one important formula, that is voltage divider rule. In simple ways, if you say whatever the total voltage it is into whatever the resistance value across the cross voltage you want to find, that resistance value divided by total resistance. So that is what the voltage divider formula. So in the next video I'm going to bring about the another combination, that is parallel one. So that's it for today. Thank you.